This is lesson 3-2 and 3-3, solving inequalities using addition, subtraction, multiplication, and division. Let's first look at the properties of inequalities. You do not have to copy this information to your paper, just watch and follow along. First, the addition property of inequality. You can add the same number to both sides of an inequality and the statement will still be true. Let's look at an example. If we have 3 is less than 8, you can add the same number to both sides and the statement is still true. 5 is less than 10. The same thing works for subtraction because subtraction is just adding a negative. So we have 9 is less than 12. If we subtract the same number on both sides or add a negative, the statement's still true. 4 is less than 7. Let's practice this in our next examples. Example number 1. Copy this to your notebook paper. We're going to solve the inequality and graph the solutions. We have n plus 2.5 is greater than or equal to negative 6. We are going to first subtract 2.5 on both sides. The opposite operation of adding 2.5 is subtracting. When we subtract 2.5 from both sides, we get that n is greater than or equal to negative 8.5. We're then going to write our solution in a set notation. You can do that right around the answer that you found. So we have the set of all n's such that n is greater than or equal to negative 8.5. Now graph our solution on a number line. Draw your number line on the blue line of your notebook paper. You should have a nice straight line when you're graphing your number line. We're going to put negative 8.5 in the center and do two numbers less than and two numbers greater than negative 8.5. As long as you're being consistent with your counting, you may count by any values you would like. Here I am counting by 0.5. So I have negative 9.5, negative 9, negative 8.5, negative 8, and negative 7.5. We're now going to graph our solution on this number line. We're going to have a closed circle on negative 8.5. Remember, extra mark, make it dark. We're now going to shade towards the greater than side. So shade the number line on the greater than side of negative 8.5. You will also shade your arrow to show that these numbers continue greater than negative 8.5. Finally, we will check our solutions. You will need to check a solution from the shaded region of your number line. Do not check the number on the dot. We're going to check with negative 8. When we add that to 2.5, we find that we get negative 5.5 is greater than or equal to negative 6. So this is a true statement. On all of your examples, you will solve, write your solution in set notation, graph, and then check. Problem number 2. Copy this to your notebook paper. We have d minus 8 is greater than negative 15. Pause the video and try to solve this on your own. Let's check your answers. You should have added 8 to both sides to find that d is greater than negative 7. Write your set notation is the set of all d's such that d is greater than negative 7. You can write this on a new line or just write your set notation around your answer. When you graph your solution, put negative 7 in the center. Do two numbers less than and two numbers greater than negative 7. Always be especially careful when working with negatives. You've got to think opposite of positives because the numbers are opposite. So the numbers less than negative 7 are negative 9 and negative 8. The numbers greater than negative 7 are negative 6 and negative 5. We'll have an open circle on the negative 7 This shows that it's not equal to -7. And we shade towards the greater than side. Also shade the arrow of the number line. Finally, we will check a solution from our number line. Remember to check from the shaded region. You should not use the dot number. In this case, -7 wouldn't even be included in our solution. Always check from the shaded region. So -6 take away 8 is -14, and that is greater than -15. If you're thinking that 14 is less than 15, then that is true, but we have -14 is greater than -15. You've got to think opposite when working with opposites. Notice we have done our solve, set, graph, and check for this problem. Example number 3. We have -3 is less than or equal to t minus 7.2. We're first going to add 7.2 to both sides. So we get that 4.2 is less than or equal to t. In order to write your set notation, your variable must be on the left. So we will need to rewrite the inequality. Here we have that 4.2 is less than or equal to t. So when we rewrite our inequality, it will now say that t is greater than or equal to 4.2. Notice the direction the arrow is pointing. It's pointing at the 4.2 in our original solution. So when we rewrite the inequality, it still needs to be pointing towards the 4.2. Write your answer in set notation. Now that the variable's on the left, we can write the set of all t's such that t is greater than or equal to 4.2. Now graph your numbers on your number line. We're going to put 4.2 in the center, two numbers less than and two numbers greater than that value. As long as you're counting consistently, however you would like to count is fine. Here I am counting by tenths. We have a closed circle on 4.2, extra mark, make it dark. This shows that it is equal to 4.2. We're going to shade towards the greater than side, also shading our arrow. Finally, check a solution from the shaded region. So we're going to use 4.3 to check. We see that this does check out. -3 is less than or equal to -2.9. Example number 4. We're going to work this problem together in class. That concludes solving inequalities by using addition and subtraction. We're now going to look at solving inequalities using multiplication and division. And you do not have to copy this information to your paper. The properties of inequalities starting with multiplication. You can multiply both sides of an inequality by the same positive number and the statement will still be true. Let's see an example. We have 7 is less than 12. If we multiply by the same positive number, our statement's still true that 21 is less than 36. The same works for division. You can divide both sides of an inequality by the same positive number and the statement will still be true. So here we have 15 is less than 35. When we divide by the same positive number, the statement's still true, 3 is less than 7. Now let's look at the properties of inequalities with multiplication and division by a negative number. If you multiply both sides of an inequality by the same negative number, you must reverse the inequality for the statement to still be true. Let's look at an example of this. 8 is greater than 4, which is true. If we multiply by the same negative number on both sides, we now get that -16 is less than -8, which is true. Notice we had to flip the direction of the inequality symbol in order for the statement to stay true. The same works for division. If you divide both sides of an inequality by the same negative number, you must reverse the inequality for the statement to still be true. Let's see an example. We have 12 is greater than 4, which is true. When we divide by the same negative number on both sides, we now have that -3 is less than -1, which is true. Notice again, we had to flip the direction of the inequality symbol in order for the statement to stay true. As a caution to you, do not change the direction of the inequality symbol just because you see a negative. For example, in this problem, 4x is less than -24. You do not change the symbol just because you see a negative. It's only when you multiply or divide by a negative that you will reverse the direction of the inequality sign. Example number 5. Copy this to your notebook paper. We have 12b is greater than -18. They multiplied by 12, so we're going to divide by 12. That's the opposite operation of multiplying. So we get b is greater than -1.5. Notice we do not flip the direction of the inequality sign just because we have a negative. You must multiply or divide by a negative number in order to flip the direction of the inequality symbol. Write your answer in set notation. So we have the set of all b's such that b is greater than -1.5, and we'll graph the solution on a number line. Put -1.5 in the center, do 2 less than and 2 greater than -1.5. Remember to keep your counting consistent on your number line. We'll have an open circle on the -1.5 and shade towards the greater than side. Make sure you're also shading your arrows on your number line. Finally, we will check a solution in the shaded region. Do not check your dot number. So we're going to check the -1. 12 times -1 should be greater than -18. This is true. -12 is greater than -18. Example number 6. Copy this to your notebook paper. We have 1.3 is less than or equal to -x. You could rewrite this -1x. There's an understood coefficient of a 1. Divide both sides by a -1. Here we are dividing by a negative, therefore we'll need to flip the direction of the inequality symbol. So our answer, we have -1.3 is greater than or equal to x. Remember, when we write our answer in set notation, the variable must be on the left. Therefore, we're going to rearrange this problem. For our answer, it will say x is less than or equal to -1.3. Write your answer in set notation and graph it on a number line. Do 2 numbers less than -1.3 and 2 numbers greater than -1.3. Be especially careful when working with negative number lines. We'll have an extra mark, make it dark circle, and shade towards the less than side. Check a number from that shaded region. You always must check in the original problem. So notice we're using the 1.3 is less than or equal to -1 times our x that we're checking, which is -1.4. We're checking in the original problem to make sure our solution is correct. It does check out. 1.3 is less than or equal to 1.4. Example number 7. We have m divided by -4 is less than negative 12. They divided, so we'll need to multiply by negative 4. The opposite of dividing is multiplying. Because we are multiplying by a negative, we'll need to flip the direction of the inequality symbol. So rewrite the symbol now as a greater than sign, and your solution is m is greater than 48. Write your answers in set notation. So we have the set of all m's such that m is greater than 48, and we'll graph this on a number line. This will have an open circle on 48, and we shade towards the greater than side. We'll now check a number from the shaded region. Remember, do not check the dot number. We want to check a number from the shaded region. So check with 49, or you can check using the next number that is going to be divisible by negative 4. The next number in that shaded region that's divisible by negative 4 would be 52. This just helps to divide evenly without having to use a calculator. We see that this does check out because it's part of our solution set. Remember, we said it was the set of all m such that m will be greater than 48. 52 is greater than 48. You can just use the next number. 49 divided by negative 4 should be greater than, should be less than negative 12. And so that does check out. You'll just need to work with a calculator if you don't choose a number that doesn't divide evenly. Example number 8. Copy this to your notebook paper. We have negative 10 is greater than or equal to 2/5 t. Here they multiply by 2/5. When you divide by fractions, that really means that you should multiply by the reciprocal. I should never see you dividing by a fraction. You'll multiply by the reciprocal 5/2. Notice we have a negative in the problem. Should we flip the direction of our sign? No, we do not flip the direction of our inequality symbol just because we see a negative. We must multiply or divide by a negative in order to flip the direction of the inequality. So we have that negative 25 is greater than or equal to t. We'll need to flip this around in order to write an incorrect set notation. Notice the arrow is pointing towards the t, so when we flip it around for our set notation, the arrow should still be pointing towards the t. So our solution is the set of all t such that t is less than or equal to negative 25. Graph the solution on a number line. Always be careful when making your negative number lines. The less than numbers need to go on the left, and the greater than numbers need to go on the right. Extra mark, make it dark. So a dark solid circle on the negative 25, and shade towards the less than side. Here we will check a number from the shaded region. Always again, remember, use the original problem. Do not use the symbol where you flipped it around. When we check in the original problem, you may choose a number that's evenly divisible by 5. In the shaded region, negative 30 would be a value that is less than or equal to negative 25. It's divisible by 5, so it makes it easy to check without a calculator. Or you can just use the next number. Negative 26 will check out, but you'll need to use a calculator in order to work it out. Example number 9. We're going to do this problem together in class. This concludes solving inequalities by multiplication and division.